Learn the essential concepts of DevSecOps and why integrating security throughout the software development lifecycle is more important than ever. Your instructor, Scott Bly, brings years of experience in cybersecurity, DevOps, and API security, and will guide you through the foundations of building secure development practices. You'll learn how DevSecOps goes beyond just adding security at the end, and instead bakes it into every stage, from planning and coding to testing and deployment. The course will also highlight the real-world stakes of modern cyber threats, the growing importance of API security, and the challenges organizations face in keeping up with rapid development cycles. By the end, you'll have a clear roadmap for making security a core part of your development process.
Hey there, I'm Dan Barahona, co-founder of AppySec University, and I'm excited to welcome you to this free code camp course, DevSecOps Part 1, taught by the veteran security engineer Scott Bly. DevSecOps is about more than just adding security at the end of the pipeline. It's about baking it into every stage, from planning and coding to testing and development. In this course, Scott breaks down what DevSecOps really is, why it matters, and how to start building it into your own development processes, whether you're a developer, DevOps engineer, or just trying to shift security left. And if you'd like to earn a certificate for completing this course, it's easy. Just go to appysecuniversity.com, take a quick assessment, and you can claim your free certificate to share with your team or network. Let's get into it and start building more secure development culture from the ground up.
Hello. Welcome to the AppySec University course on API security in the world of DevSecOps. I'm Scott Bly, and I'm going to be your host during this course. I'm the Director of Security Technologies for System Integration Solutions, and I've been there for a little over a year. I run the Cybersecurity Professional Services Business Unit. SIS has a long history of about 35 years in professional staffing and security teams placement, DevOps engineers, etc. And prior to being at SIS, I was at No Name Security, where I ran a number of accounts as a senior technical account manager on the cybersecurity side of things. And I made sure that customers who made the investment into an API security product had the results that they were looking for in terms of the tooling being used appropriately and collecting the data that they're looking for to achieve the security objective that they need for their security program. Prior to that, I was at AWS, where I ran the Enterprise Support Security Improvement Program. I was also a senior technical account manager there, and I ran a number of very large customers' AWS operations. And the Security Improvement Program was a very interesting security program that I enjoyed quite a lot. What we did was we looked at customers' cybersecurity capabilities holistically, from hiring and training through all the way to the very granular aspects of how are you implementing security groups? How are you handling tagging? And what we did is we provide customers with a way to measure their cloud security posture and make informed, data-driven decisions about how to adjust their resource allocation from people, training, software packages that need to be purchased, etc., so that they can improve their security posture in a measurable way, and they could repeat that process and see how they were doing. So very much assessment-based, but what it did is it provided a lot of value to customers so they could determine how they need to readjust their priorities. Prior to that, I have been the director of IT and cybersecurity, and I also was a consultant and ran my own cybersecurity and IT consulting business in Southern California for about 15 years. So I like to say I've seen a lot of what can go right and what can go wrong in the IT and cybersecurity space. I'm very happy about the course that we're going to be teaching here. Now, our agenda, this course is going to be chopped up into 3 different parts. The first part we're going to be doing today, or however long it takes you to get through this course. And starting with the introduction, which I've just completed, we're also going to talk about what are the stakes? Why do we care about this subject matter in the first place? Why DevSecOps, and what do we even mean by that? And why API security? Now, this course is primarily going to be about the DevSecOps side of things, but we're going to bookend it all with API security because that's what we're really driving toward. And then DevOps versus DevSecOps. You can't understand DevSecOps without understanding DevOps properly first. And then we're going to do the first of our overview into DevSecOps with the principles that make DevSecOps relevant and important. Last but not least, it's not all just bits and bytes. It's about the people. So we're going to look at How do people work within a DevSecOps cultural transformation? And what are they trying to achieve? And how can you help your organization get there better? And last but not least, contact. How can you get a hold of me and SIS so that we can help you with your security needs, or if you have any questions about the course? The future parts are going to be a DevSecOps deep dive. We're going to look at every single step of the process from planning to feedback and monitoring within the DevSecOps lifecycle for software applications. And then part 3, we're going to take that same deep dive and we're going to go even deeper into the API security side of things. This is going to be quite a lengthy course, I believe, and we're just on part 1 right now. So without further ado, let's get started. So what are the stakes here? Why do we care about this DevSecOps and API security situation? The truth is, we're at war. Cyber breaches are now an active part of armed conflict, if not a leading indicator of physical warfare. Russia's first cyber attack on Ukraine and their power grid occurred in December 2015, fully 7 years before the most recent invasion. China, North Korea, Russia, these are all nation-state actors that actively target U.S. government data resources, as well as the political parties on both sides of the aisle. But government isn't the primary target. According to Mandiant, financial services firms are twice as likely to be targeted as government orgs last year. North Korea funds many of its activities via ransomware payments and the Bitcoin payments that they generate. And organized crime is part and parcel to Russian government activities, and this includes cybercrime. Chinese hackers have been exfiltrating intellectual property from U.S. firms for years. The war has come to us, whether you're in the U.S. or you're elsewhere, as we're seeing Europe is in a destabilized situation, so these problems are everywhere. The government isn't coming to save the day. Let's set aside the latest headlines about CISA and DOGE. I'm recording this in summer of 2025. With regard to a breach, there is a fundamental disconnect between law enforcement and their requirements to gather evidence by setting the bait versus the private sector's need to simply stop the bleeding and get back to revenue-generating activities at minimal cost. This is before we even touch upon the complexities of international jurisdiction. I'm sure we all know that we can use VPNs and appear like we're anywhere in the world. Not only is the government not coming to help, they're partially responsible for this entire mess. The NSA's stockpile of zero-day attacks that had been paid for in the late 90s and the early 2000s was hacked and stolen and sold on the dark web 10 years ago. That was in 2014, I believe. So if it seems like attacks are on the rise, they are. The bad guys have access to the same capabilities as the good guys, including AI, for all of their attacks at an unprecedented scale, and they only have to succeed once. The good guys have to win every single time. Now, I know we're talking to a global audience here, so hopefully it's mainly good guys that are going to be watching this. But the truth is that cybercrime now costs $10 trillion annually. According to IBM, the average cost of a data breach is now $4.9 million. But that breach brings with it not just costs from remediation and fines and consulting fees and the like, but indirect costs like business impact, lost customers, lost IP, lost trust. And don't forget the cost of the free identity protection that we all get about 8 to 10 times a year. Large firms face greater financial risk in the aggregate, but a smaller firm faces greater risk existentially. Small and medium-sized businesses are hit more often by total volume and with greater direct impact. And in fact, bankruptcy is not off the table. So for those of us that are attending courses like this and learning about API security and left responsible for securing our organizations, we're the ones left holding the bag. Our code, our applications, and infrastructure are the front lines in an economic war where every new innovation that we come up with is a weapon that can be turned against us. So why DevSecOps? The reality is that threat actors cannot breach an organization and steal data or plant ransomware or any of the other activities that they do if there aren't vulnerabilities. So what they're doing is exploiting vulnerabilities. And it's the role of developers and infrastructure managers to control those vulnerabilities, either through preventing them from existing in the first place or putting in compensating controls. The success of DevOps over the last 10 years or so in making sure that developers have the ability to get code to market quickly in a very reliable and repeatable way has led to an increase in vulnerability rates. Now, why is that? How did that happen? as developers are able to get code to market faster and faster, the security teams fall further and further behind, unfortunately. We all know that it is more efficient to fix code problems in dev versus ops. Once code is running in production and you have customers relying upon it, it's incredibly difficult to make those changes and have them not be breaking changes in many cases. So if you can fix those problems in the development cycle prior to release, you're going to end up with a much more satisfying and efficient outcome. The problem is there's about a 1,200 to 1 ratio of developers to AppSec engineers, and that ratio isn't improving anytime soon. So as a result, there's an enormous workload for AppSec teams to keep up with the pace of innovation and code release that the developers are putting out into the world. And they just can't do it. It's not really possible. So when we look at DevSecOps, the concept is applying DevOps principles to security as well, and making sure that security is involved with the DevOps process at every stage. We're going to get into more detail about that here pretty soon. But when you start looking at how to accomplish this, it's not just, we're going to stand up some tools. It's technology, it's processes, and it's the people that are involved. And then through the course of this program, in 3 parts, we're going to be talking about how to accomplish all of those aspects. And the thing to remember is there's going to be a lot of information that comes at you about DevSecOps through this course. But don't feel like you have to do all of it at once. It's supposed to be an iterative lift, not a burden. You make one change, get it through your next sprint. Make another change, get it through your next sprint. The process is meant to be one that you take on through cycles. It's part of your daily work to improve the work, and we're talking about exactly what that means shortly. Now, why API security? 85% of web attacks are now API attacks. Gartner predicted a few years ago that APIs were going to become the #1 attack vector, and that has now come to pass. Why is that? There's a common phrase that data is the new gold. It's the most valuable resource on the planet now. As a result of that, you have an enormous number of malactors trying to gain access to that data at the exact same time that organizations are trying to monetize that data and get it out to market and sell it to partners, etc., in order to extract the value that they have in the data that they control, whether it's an AI application or whether it's traditional data mining or whether it's just selling personal information that you've approved by allowing yourself to be sold. Remember, anytime you are consuming something that's free, you're the product. So what you want to do is protect your data. And when it comes to the DevSecOps world and to API security, with the absence of the perimeter in modern architectures for software, the data itself needs to be the new perimeter. So when APIs have access to data directly the way that they do, we end up with a tremendous attack surface of data that has the ability for malicious actors to be able to take that data and extract it at scale. Because of the modern software architectures that exist, think microservices, think serverless architectures, etc., APIs are how all of that communication takes place. And as a result, an API vulnerability and an exploit that takes place in one environment can impact another environment. And that means not just apps that are connected between different functions and services within one organization, but when you're consuming resources from a third party, from a business partner, you can also impact their organization. If the prices that you sell your goods and services for are maliciously changed, that can impact your partner who is consuming those prices through your APIs. So that's just one small example of how you can have a data breach on your side that affects a partner. So that's one of those indirect costs, but it's not just about you anymore. The other thing that's important about APIs, I've had people tell me, oh, we have APIs, but they're all internal. So we're not really worried about API security. I'd ask you, what about ransomware? That affects internal networks. That affects data servers and backup servers and everything else. Those aren't open to the public. And yet, through a lateral movement exploit, once a malicious actor lands on a system, they're able to then pivot and attack another system. APIs have the same problem. If an API is internal, sure, it's behind some protected network. You have various VPC security controls in place like ACLs and security groups and other checks. But that doesn't mean that a lateral movement exploit can't still take advantage of your API infrastructure, even for an internal private API. So just because it's internal doesn't mean it's secure. This course isn't going to go into, in part 1, a lot of detail about API security, but I want to make sure that we maintain the reference of API security around this entire conversation over the next several hours as we get into all of this information, because API security is where we're driving, but we have a lot of groundwork to cover before we really get into the API security details. Now, as we do that, what I want to do is make sure that we stay focused on the foundation of API security. We're going to be mainly talking about DevSecOps in this part, but API security I want you to keep in your mind. The 4 fundamentals are discovery, which is API asset inventory, change detection, network mapping, and reconnaissance. What I mean by that is there's an old saying of, if you can't see it, you can't protect it. It's an old adage in the cybersecurity space. And that's absolutely true with APIs as well. One of the fundamental problems with the API ecosystem these days is that organizations have far more APIs in play than they realize. They have no idea how many APIs they have. They don't know how they function, what their purpose is, who owns them, how they're authenticated, etc. The problem is pervasive throughout the entire technology industry. I've seen it with my own eyes. Now, once you see something, once you have discovery under control and you have an inventory, the next step that you want to take is posture management. I typically think of this primarily as vulnerability management. There's more to it than it's not just vulnerability of code, it's vulnerabilities in your infrastructure, configuration control. And also, how do you prioritize remediation of vulnerabilities once they're discovered? Posture management can also be thought of the first baby step in your shift left process, which is a lot of people think of DevSecOps as shift left, but it's not. There's more to it than that. So posture management is the first baby step left because a vulnerability hasn't necessarily been exploited yet. So it's the first step left in the timeline. On the right-hand side of that same timeline, you have runtime protection. Did a bad guy do a bad thing at a particular point in time? I've heard people say right of boom. So you have a bad event that's taken place. It takes place at a certain point in the timeline. To the right of that is everything that takes place after: incident response, remediation, getting back to a proper business function, etc. Runtime protection is responsible for the shift right side of things, where you have running workloads in production that are perhaps being exploited or that have anomalous behavior within the application and within the APIs that consume the application. Runtime protection is how you observe that. So you're detecting and preventing attackers and suspicious behavior in real time. The fourth component of API security in these foundational concepts is active testing. And what I mean by that is essentially dynamic application security testing of your APIs. Remember, APIs are about code consumption. So static testing, aside from the API spec file, the open API spec file or a Postman collection, aside from those two components that you're going to scan, the API testing that you do is primarily dynamic. It requires a running environment. When you're thinking about shift left, that active testing component is where everything really comes together. So we're going to talk at length about that and about the various stages that lead up to a testing capability in the DevSecOps portion of the course that we're going to get into shortly. Active testing is about securing your APIs in dev, that's that shift left motion, to stop vulnerabilities for production. Next up, we're going to talk about DevOps. To start to understand DevSecOps, we first have to understand DevOps. DevOps has come about as the primary methodology for releasing code to market faster than ever before and more reliably. So DevOps, as you can see here, we have a diagram that describes the development cycle, a feedback loop here, and an operations cycle with its own feedback loop, and they're connected. Across each of the two stages of DevOps, you have 5 individual stages within each cycle. We'll start with the planning phase. Planning is where, just as the name implies, you are determining what your software application is going to be. It might be at a bar on a napkin, you're sketching things out, It might be a very lengthy and involved planning stage. When we get to the deep dive on DevSecOps, we'll go in depth on what all of the different steps could be for a planning stage. But the main idea here is that it's before you actually start writing any code. Next up is the development stage. The development stage is where the code actually is written. Your developers are using their IDEs and they're getting all the code written until they have a functional, capable solution. Then build stage is where they are starting to construct the software application into a consumable resource. And then testing is when you're validating that it actually works the way that it's supposed to. Now, notice that at the testing stage, the development cycle feeds back into itself. You may conduct a series of tests and determine, this isn't actually working the way that I meant for it to. I need to make some changes, or we need to improve performance, or we need to improve reliability, or it may result in inaccurate results, garbage in, garbage out, etc. So you may feed back into a development cycle again. Now, in the DevOps universe, this is typically done in sprints, where you'll develop, build, and test, develop, build, and test. And eventually you'll have something that's ready for release. And in fact, you may have a release candidate. The release candidate begins to exit the development cycle and enter the operations cycle. The operations cycle begins with delivery. Delivery is different than deployment. Delivery is making sure that the code is ready to be deployed. We'll talk more about that in depth later, but it's preparing for deployment. Deployment is actually putting the code into production, wherein the code is actually delivered to a customer and is consumable. Next up is operations phase. While you're operating, so the operations cycle includes an operate phase. The operation phase is where your code is running with customers and you're observing the results in the monitoring phase. So operations has a lot of maintenance activities and things like that are involved. Monitoring is about being able to feed that cycle of information of what you're observing back into deployment, and you're continually observing what's happening. So the operations phase is also running its own cycle. And you may end up running in the operations cycle for quite a long time while nothing's happening in dev, or both of these cycles may be running at the same time. And you're continually kicking stuff off from one side to the other. Now, once your operations cycle has run for a while and you're ready to feed that information, the lessons you've learned back into the overall process, you're back into the planning stage. And that's why these are connected. So they feed back and forth into each other on a continual cycle. Now, the beauty of DevOps is that it has enabled us to get code to market fast. It's enabled it to be done reliably. Think about infrastructure as code and lots of other capabilities that come along with the ability to do these things in a very reliable fashion. Modern app teams are able to release code to market as often as thousands of times a day. Companies like Google and Amazon have enormous software development capabilities, and because they adhere to DevOps principles, they're able to get code out very fast. Let's talk a little bit about the history of what that looks like and what it means to be able to accomplish this. In order to understand DevOps, we need to talk a bit about software development history and the way that projects used to be managed. Once upon a time, in the olden days, software was delivered on floppy disks and CD-ROMs and DVDs more recently. This is before the era of downloading everything and it just all worked. In order to get that product to market on a CD-ROM, the methodology that was typically used was called Waterfall. And what that meant is you had a series of very linear steps that were undertaken. So you have requirements phase, design phase, implementation, testing, and maintenance. And what would happen as a result of that process is you would end up with a very well-defined CD-ROM or floppy disk set that was mailed out or available in retail stores for customers to purchase. Now, there might be updates that were available, etc., for download, but this was in an area when that was not a very particularly feasible methodology. Nowadays, Agile is the project management philosophy that's in place more often, and it has a number of advantages. As you can see from the diagram here, you have a more of a cyclical nature that very much resembles the DevOps cycle that we just saw. You start with a backlog of requirements that then moves into an analyze phase. The analyze phase lets you determine what should you be working on. You define what the sprint is going to look like, you design it, you test it. And then ultimately it's deployable, right? And you go through that agile phase, that agile process regularly, typically in sprints that last a week, 2 weeks, a month, however long your sprint cycle is. And you're able to get code to market very quickly. And this is the project management side of things. The advantages of Agile over Waterfall are speed to market, team ownership, because your team takes full ownership of the entire development cycle rather than it being done by a committee or having been defined early on by a different team. And then your development team is only responsible for the delivery of the code you've been assigned. Your team is involved in the design stage and everything. It's all very much a closely knit group. Client engagement is much higher in an Agile methodology because each sprint, you're checking in with the client or the end user in order to determine, are we making progress toward the goal? Are there items that need to be updated and changed, etc.? And then last but not least, error remediation. Because you're going through this testing cycle more quickly, you're able to remediate problems that occur much faster. On the waterfall side, the advantages are that it's very linear with testing. So if you think about something like a rocket launch, once upon a time, waterfall was the way to do that. We'll talk about more about that in just a moment. But if you're going to launch a rocket into space, you better get it right the first time. That was the thinking. As a result, you end up with lots of testing, very expensive, it's slow, but ultimately you get something out that's perfect, or as perfect as you can make it. It's very structured, lots of planning steps, and there's a light touch from the client. The client is going to be involved at the early stages in order to determine what are we trying to accomplish and how are we going to get there. And then you go away, you do the thing, and you come back and you've got a completed activity. The other thing that's good about Waterfall is team efficiencies. Your team is only engaged on the part of the work that you need to do at any given time versus Agile, where the entire team is involved the whole process. And last but not least, one of the advantages of Waterfall is sequential deliverables. You know what those deliverables are going to be, you know what order they're going to occur, and it all takes place in a certain order. Under certain circumstances, that makes a lot of sense. The traditional thinking was that even made sense for launching rockets. SpaceX has obviously proven that is not necessarily correct. By building inexpensive rockets, launching them and watching them blow up and figure out why they blew up, you're able to get rocket development to occur faster. And this has led to a revolution in how a space launch takes place. The other thing that's important to know about Waterfall versus Agile is that in business, speed matters. And so Agile's ability to get code to market faster has proven to be a real game changer. And the other thing that's important, I spent some time at AWS, as I mentioned, and Amazon is fairly famous for its two-pizza team methodology. What's interesting about that is that the two-pizza team, the idea is that any team that's responsible for a work product should be able to be fed during a meeting by two pizzas. That means the team size is relatively limited. And if your team grows beyond that two pizza size, you should cut the team up and divide that workload into different groups because you have too many people working on one thing. It should be divided up into smaller chunks of work. We'll talk more about that shortly. But what's interesting about how Amazon has done that is it's taken a microservices software architecture approach and applied it to business use, to business methodologies. As a result, much of the Amazon business is run like many series of tiny startups. Each business unit is responsible for its own work output. It's responsible for the analysis, the definition, the design, the testing. Everything is very agile. As a result, Amazon's been able to move very quickly. Many other companies follow this methodology as well, but it's a very agile approach toward business as well as software development. Now we're going to talk more about DevOps, but to talk about DevOps, we're going to talk about manufacturing first. It's important to understand where some of these ideas came from. In the 70s and the early 80s, Toyota was basically beating all of the American auto manufacturers at their own game. They were making cars faster, less expensively, and more reliably than the American manufacturers. And no one could quite figure out how they were doing it. The way they were doing it was the Toyota production system, which was really based on lean manufacturing. Nowadays, we understand what lean manufacturing is, but at the time, it was a revolutionary idea. In order to get these ideas out into the world so that American manufacturers could start to take advantage of Toyota's capabilities, there were books written. Some of these were here. The Toyota Way was the first. It was written by Jeffrey Liker. But the one that really changed the way that American business worked was a novel called The Goal, and that's what's on screen now. It was written by Eliyahu M. Goldratt, and it was published in 1984. And instead of being dry business text, it was a novel. It was paced like a thriller about a team that needed to adopt lean manufacturing in order to save the business. Very compelling story, characters that you could relate to. People had their own home lives and things like that. Everything you look for in a novel was present in The Goal, yet it took place in a scenario that popularized this lean manufacturing concept. And one of the important parts about Toyota's system is called the andon cord. The andon cord is a cord that was literally hanging by each production station and the Toyota manufacturing plant, where if a worker observed a problem of any size or any scale, they could pull the andon cord and the entire assembly line would come to a screeching halt. It did that so that all of the other workers that were the best in their field would come descend upon the problem that had been observed and identify a solution to the problem so that it could be remediated, fed back into the manufacturing process, and then the production line would start again with that problem resolved. As a result, you have fewer and fewer errors, fewer and fewer defects make it out to customers, and you have a more reliable product. This was a revolutionary concept, wildly expensive in the American sense, but Toyota had a different culture and philosophy about how to get product to market, and it was that pride of ownership and pride of work product that really made a big difference. And the Toyota production system is how they were able to accomplish that. Now, as a result of the success of Toyota's process, lean manufacturing, and The Goal popularizing all of that, lean manufacturing from 1984 until, let's say, 2020, was absolutely the way to approach business. As a result, you end up with very fast time to market for products, just in time manufacturing and supply chains, where your supplies that you need to build a product arrive just as you need them, which made for very efficient, lean manufacturing approaches that kept costs down, kept supply chains moving freely. That was all great right up until the pandemic basically blew up global supply chains, and we discovered there were some problems with that. In the software world, we would define that as a high availability and resilience problem. We'll talk more about that later. But the high availability problem was made very apparent as a result of the pandemic. Now, why am I talking about this Toyota process? Because for many years, it was thought that applying Toyota's lean manufacturing technique didn't make any sense in the world of software. It's not a physical thing. You don't have stuff that needs to get shipped around, and it was a different process. Enter the Phoenix Project. In 2013, Gene Kim, Kevin Baer, George Spafford wrote the Phoenix Project, which was a novel based on The Goal, but it was about DevOps. It was about software development and release and IT operations. Now, it was primarily focused on the operations side of DevOps. How do you get work done? How do you get things out the door? How do you monitor them? How do you improve processes and procedures? And it was about the overall workflow methodologies. Now, what I have on screen here not only is the Phoenix Project cover, so you can go find it. I consider it required reading. The Goal is background reading, but the Phoenix Project is essentially required reading for anyone that works in software, security, DevOps, any of this. If you haven't read the Phoenix Project, please go read it. The audiobook is available. It's great as well if you have a commute or just like to have things on, listen to audiobooks or podcasts in the background. Please get it. It's available at the library, I'm sure, as well. The three most important concepts in the Phoenix Project are called the 3 ways. Now, normally I don't read directly from the screen, but I'm going to make an exception in this place because I feel like these 3 concepts are important enough that they really define what we're talking about in DevOps, and as a result, what we're talking about in DevSecOps. Because again, you can't understand DevSecOps without first understanding DevOps. So the first way is called flow. And I'm quoting, "The first way enables fast left-to-right flow of work from development to operations to the customer. In order to maximize flow, we need to make work visible, reduce our batch sizes and intervals of work, build in quality by preventing defects from being passed to downstream work centers, and constantly optimize for the global goals. By speeding up flow through the technology value stream, we reduce the lead time required to fulfill internal or customer requests, especially the time required to deploy code into the production environment. By doing this, we increase the quality of work as well as our throughput and boost our ability to out-experiment the competition. The resulting practices include continuous build, integration, test, and deployment processes, creating environments on demand, limiting work in process, WIP, and building systems and organizations that are safe to change. This is from the DevOps Handbook, which I'll talk about in just a moment. This is where the flow way is defined very clearly. In the Phoenix Project, there are a series of conversations that get at this and makes it very easy to absorb. What I'm going to do now is we're going to go back through that whole statement and kind of break it down a little bit and understand it a little more clearly. So the first way enables fast left to right flow of work from development to operations to the customer. So this is talking about that same timeline that we talked about earlier on of shift left and shift right. So the right-hand side of the timeline is, in the security sense, is after something has occurred. In the software development sense, the right side of the timeline is code being released to customers for consumption. Here, we're talking about the same thing. Development on the left-hand side, operations through to the customer on the right-hand side. You have the same thing with the DevOps cycle where they're both there. Development is on the left, operations is on the right. Now, the first way enabling fast flow from left to right means speed to market. The next sentence, in order to maximize flow, we need to make work visible. Visible meaning transparent. Your teams need to have open communication so they understand what they're working on. You need to have work streams that are visible to the other teams so everyone has an understanding of what's occurring in any workflow. If you think about Confluence and the Jira software development tool, the Jira, the software development tool from Atlassian, you have the ability to go look at tickets and see what's being worked on. You have the ability to see the different work streams. It's important to make sure that your teams know what's going on. You reduce your batch sizes and intervals of work. What that means is instead of taking a monolith, a giant project, and working on it all at once and testing it once it's all complete, you break it down smaller and smaller. This is the idea behind microservices. This all works because when you're working on a very tiny piece of code, rather than testing all of Windows, if you're just working on the clock, that's something that's much more bite-sized that you can test more efficiently in order to make it updatable, maintainable, testable, and releasable. So reducing batch sizes means you're also working on smaller sets of work within that small piece of work. So using the clock analogy, if you're making an update to the way that the clock works, maybe you're just updating the way the second hand moves around. How does it refresh on the screen, etc. Maybe you're working on a timer that's part of the clock application, or maybe the timer itself needs to be spun out as a separate application. Constantly reducing your batch size is one of the first ways to achieve fast flow from left to right. Intervals of work also. The idea of a sprint. Sprints are typically about 2 weeks long. Maybe you have longer sprints because you're starting your DevOps transition to get away from waterfall methodologies. You're trying out Agile, but you still need to make that adjustment. Maybe your sprints are longer at first. As you make the sprints shorter and shorter, you're automatically going to be making smaller and smaller changes to the code, which means your batch sizes reduce, as well as your interval time between start and stop period for your sprint. Next up, build in quality by preventing defects from being passed to downstream work centers. That's the and-on chord. When you observe a problem, you stop the line, you fix the problem before it makes its way on. That's the idea in CI/CD pipelines of if a test fails, you don't publish it. It doesn't get to build. It doesn't get to the integration stage because you've stopped that build process and the developer has to fix it before it can move on. That's that concept being built into software. And constantly optimize for the global goals. So you're always keeping in mind the objective of the organization and your overall project rather than just being focused on your specific work task. This is the idea of not losing sight of the forest for the trees. By speeding up flow through the technology value stream, we reduce the lead time required to fulfill internal or customer requests, especially the time required to deploy code into the production environment. That's the whole idea of moving fast from left to you're getting all of your development and testing work done so that you can make its way to production to service customers, whether they're internal or external. By doing this, we increase the quality of work as well as our throughput and boost our ability to out-experiment the competition. Out-experimenting is one of the important concepts here. When you are constantly releasing new ideas and innovations to market, sometimes they're great ideas, sometimes they're not. Amazon's Fire Phone, I think it was called, was an example. They spent a ton of money on it, and it was a spectacular failure. But the VP that was in charge of that project, once they announced that they were pulling out of it, went to lunch and was the first to arrive with Jeff Bezos there. This is a story that Bezos has told many times. When he arrived, he sat down at the far end of the table because he just expected an absolute tongue lashing because Bezos could be pretty famously difficult. However, Bezos asked him to come sit down at the table next to him, and before anybody else got there, he said, "Look, I don't want you to apologize for anything. We made a big swing, and it was a miss. But if you don't take the big swing, you never connect. You never hit a home run. You miss 100% of the chances you don't take." So that was a very important thought for Amazon to be able to have such a large experiment not work out, and yet heads didn't roll, etc. What they were able to do was take a lot of the technology that they developed for that Fire Phone, and they were able to put it into, I believe, it ended up being a big part of Alexa, which obviously was a huge hit and remains so to this day. So the idea of experimentation, getting code and features and capabilities to market fast so you can see what works and doesn't work, gives organizations a huge advantage. And that advantage sometimes works out, sometimes it doesn't. But overall, by getting code to market fast, you're able to try things faster than the competition. And that's what gives you an edge in business. And it all starts with the ability to get code to market faster. So each of these things are really about supporting business outcome, and that's what it's all about. The resulting practices include continuous build, integration, test, and deployment processes. We'll talk about all of those steps later. Creating environments on demand. This is the idea behind infrastructure as code. Limiting work in progress, WIP. They talk about that a lot in the Phoenix project. It's essentially what's being worked on at any given time. When you have too much happening all at once, it becomes unwieldy. When you reduce that batch size and all of that, you're able to work more efficiently and get things done quicker. And last but not least, building systems and organizations that are safe to change. The operations cycle, when work is in production and customers are consuming it. If you have smaller batch sizes and have done all of the things that are necessary on the left-hand side in development, that means that when you make an update and it goes to production, it's less likely to be a breaking change that will interrupt production for customers. As a result, you have a safer environment that you are able to experiment within more easily. You can try something out. And part of that has to do with high availability and resiliency. Is your system going to withstand changes that could be breaking? And also, do you have the ability to do like A/B testing and canary testing when you're releasing features so that they can be consumed on a more bite-sized capacity and by smaller numbers of customers, so that if there is a breaking change, it doesn't break everything for everyone, but only for some. So that's from the DevOps Handbook. I haven't talked about the DevOps Handbook. It's up next. The DevOps Handbook, I consider recommended reading. What it is essentially a follow-up book to the Phoenix project that was published in 2016. It was written by Gene Kim, Jez Humble, Patrick Dubois, and John Willis. And what it is really real-world case studies of effective DevOps implementations from the people who did it first. So you'll read about folks from Google and Pinterest and eBay who developed a lot of these capabilities and put them into play, and what were their real-world business use cases. So it's not a novel, it's a project, it's a business management book, but it's very much following on to the same concepts that were made human in the Phoenix project. On this screen, I have the second way. Remember, there are 3 ways that are talked about in the Phoenix project. The second way is feedback. I mentioned feedback loops earlier on when we were looking at the DevOps cycle, the 2 things feeding back to each other. The second way is feedback. The second way enables the fast and constant flow of feedback from right to left at all stages of our value stream. It requires that we amplify feedback to prevent problems from happening again, or enable faster detection and recovery. By doing this, we create quality at the source and generate or embed knowledge where it is needed. This allows us to create ever safer systems of work where problems are found and fixed long before a catastrophic failure occurs. By seeing problems as they occur and swarming them until effective countermeasures are in place, we continually shorten and amplify our feedback loops, a core tenet of virtually all modern process improvement methodologies. This maximizes the opportunities for our organization to learn and improve. Like I said, from the DevOps Handbook. I'll go through these again quickly. I think the sections of the course so far where I've talked about these concepts should already be fairly clear, so I'll belabor the point. But second way enables the fast and constant flow of feedback from right to left at all stages of our value stream. Remember, we're trying to make work flow from left to, but the idea of feedback moving from right to left enables the later stages to inform the prior stages. Remember, the operation cycle is going, and it's going to feed back into the development cycle. That feedback loop of all of the learnings from the operations, what happened when the code was running in production, getting back to your development cycle informs the developers of what should change next. Typically, this looks like tickets in Jira, etc., but the concept is what's important. It requires that we amplify feedback to prevent problems from happening again or enable faster detection and recovery. So the faster you find a problem on the right, or even during testing on the left-hand side in development, the faster you find a problem, the faster you're able to fix it. That's the idea behind shift left. You want all of your problem detection to happen earlier, including security remediation. We're going to talk about a lot later, but right now it's about these principles of moving problem detection and fixing from right to left. And that requires a feedback mechanism. By doing this, we create quality at the source and generate or embed knowledge where it is needed. So again, getting the developers what they need early on so that they can fix the problem. This allows us to create ever safer systems of work. I talked about that with the experimentation, where problems are found and fixed long before a catastrophic failure occurs. By seeing problems as they occur and swarming them until effective countermeasures are in place, remember the and-on chord, that's the same concept, we continually shorten and amplify our feedback loops. The other thing about the and-on chord when applied to modern software development is typically that's going to be a war room. You've got a team that establishes a call where everyone is able to get together, you do screen sharing, etc. These are techniques that we all use, but this is where these ideas come from. We continually shorten and amplify our feedback loops, a core tenet of virtually all modern process improvement methodologies. This maximizes the opportunities for our organization to learn and improve. That feeds into the third way, is continual learning and experimentation. Now, the third book that I have here, which is also recommended reading, is The Unicorn Project. This was published in 2019. It was written by Gene Kim as a solo effort. It is also a novel, and it follows the same storyline as the Phoenix Project, but it's a different team. It's the actual software development team. You remember how I mentioned that the Phoenix Project primarily talked about operations and workflow? The Unicorn Project primarily deals with the development team that was responsible for all the software that was being written during the events of the Phoenix Project. So if you're interested in software development and DevOps, which clearly you are by taking this course, I recommend the Unicorn Project as well. Now, the third way, continual learning and experimentation. The third way enables the creation of a generative, high-trust culture that supports a dynamic, disciplined, and scientific approach to experimentation and risk-taking, facilitating the creation of organizational learning, both from our successes and failures. Furthermore, by continually shortening and amplifying our feedback loops, we create ever safer systems of work and are better able to take risks and perform experiments that help us learn faster than our competition and win in the marketplace, also from the DevOps Handbook. So this is about the third way. I'll go through it again really quickly. Third way enables the creation of a generative, high-trust culture that supports a dynamic, disciplined, and scientific approach to experimentation and risk-taking. Now, the high-trust culture, we're going to talk more about this later on, but this is the concept of psychological safety. You trust each other. You trust that if a mistake is made through an experiment, that you're not going to end up getting fired for it, that kind of concept. And this is particularly important in the security field. We're going to talk about that a little bit more later. The disciplined scientific approach to experimentation and risk-taking means having data to make decisions about whether or not an experiment is working out or not, or whether a risk is worth taking. But you still take that risk. Amazon also has the concept of two-way doors. Some doors are one way. The big decision that's very difficult to walk back the decision and undo it. Whereas a two-way door, you make a decision, you walk through the door, whoops, that didn't work out. You walk back through the door. Not a big deal. Two-way door decisions can be made very quickly. Doesn't matter if they work out or not. You hope they do, but it's part of your experimentation culture. One-way door, those are higher level decisions that typically go further up the command chain for that decision to be made. But those one-way decisions are typically a lot harder to undo. But for the most part, you want to be making lots of small two-way door decisions that have risk and experimentation built in, because that's what you're trying to do, is take big risks. Facilitating the creation of organizational learning, both from successes and failures. Biggest problem with failure is if you do not learn the right lesson from that failure. Learning and resource allocation to professional development is an important part of any organization. And I'll talk more about that later when we get to the people part of this whole course, but the organizational learning is a really important concept I want you to remember. Furthermore, by continually shortening and amplifying our feedback loops, we talked about that before, but the feedback loop is where the learning takes place. We create ever safer systems of work that prevents catastrophe and whatnot that we talked about in the last step, and are better able to take risks and perform experiments that help us learn faster than our competition and win in the marketplace. If you're learning from your experiments, you win. The Fire phone example, they learned that the world doesn't need another phone operating system. What they did need was something cool that does voice interactive computing, Alexa. And of course, you have other things like Siri that have followed along with that as well. So that's also from the DevOps handbook. Now, continuing on our DevOps learning trajectory, we're going to take a look at the DevOps software factory. And this image that I'm sharing comes directly from the Department of Defense DevSecOps strategy guidebook, which I'll be referencing periodically throughout this course, and I'll provide links to the downloads here momentarily. But this shows a DevOps software factory. Now, as we've discussed, DevOps has enabled fast release of code to market, predictable results, and things like infrastructure as code, where you're able to compose an entire running environment in the cloud, for example, on demand. What does a DevOps software factory really look like? So you start with the code itself, which is here in the top left. The developer is writing the code, and it is typically done within an IDE, an integrated development environment, or it is imported into an IDE. What that does is it enables you to publish your code from the IDE and store it into a code repo. Now, that code repo, whether it's in the cloud or a local artifact repo, then pushes your code into a development environment where the first round of testing and build activities take place. So that's considered one of your potential pipelines, where you're going to have different sets of code that run through those pipelines in order to ultimately make their way to an integration and pre-production environment. That first stage is called continuous integration, which is denoted here in the little gears with the CI. So you've heard of CI/CD pipelines. That's CI, and this is CDs, continuous delivery. So you're continuously integrating your built software, integrating it into a testing environment for further testing, and then it gets delivered into a continuous delivery mechanism into an integration and pre-production environment. That's where you're able to undergo broader system testing. Ultimately, that delivery is released. As we talked about, release is different than deployment, and that released artifact repo is then ready to be deployed somewhere. Now, when the software factory is in place, you typically have controls for different levels of testing that need to take place either at the build stage. If something fails a build, it goes right back to the developer. If you're integrating and something fails, test in your testing environment, same process. It doesn't make its way through to the next higher environment, and the developer gets the software kicked back, and they've got to make their remediations. Whether we're talking about reliability, performance, function, business function, logic, errors, or security problems, the same thing holds true throughout all of this. We're going to talk about security here momentarily. When we look at the DevOps success and the ability to get that code to market as fast as it has, what has happened, unfortunately, is the good side is that it's made its way to market faster, as we talked about with all of the DevOps stuff we were just discussing. The bad part is that there are also higher rates of vulnerabilities. And what has caused that? The vulnerabilities that are present in code are there because developers aren't necessarily trained in security. The people who are trained in security end up working on the AppSec side of things. So they end up running the tools like your static analysis tools and your dynamic analysis tools and your software composition analysis tools, all the stuff that happens in the AppSec side of the world. Those folks are typically not primarily trained as developers. They may have some coding chops. But you have these two different skill sets that are working. And unfortunately, you have a ratio of about 1,200 to 1 of developers to the security team. So you end up with these higher rates of vulnerabilities. When we look at the DevOps lifecycle, the question is, what's missing from this picture? And the answer, of course, is security. That's why we're here. This is a DevSecOps course, and what you're seeing missing, as we've talked about DevOps, is the sec part, the security component. So as a result, of this missing security component, what a lot of organizations have done in order to start down the DevSecOps path in their perhaps cultural transformation is they start to shift left, which is great, but it's not enough. We'll talk very explicitly about the Department of Defense frameworks for DevSecOps. But what I want to do first is look at what typically happens on an organization's journey into DevSecOps. And we will do that in the next section of the course, which we dig in on DevSecOps. And without further ado, we are finally to the DevSecOps portion of the course, the whole reason why we're here, right? So what we have on screen in front of us now is the DevSecOps software factory. This is an evolution, if you will, of the DevOps software factory that we saw in an earlier slide. Now, many organizations, when they say we're going to embark upon a DevSecOps cultural transformation, what they do is they add security testing into their CI/CD pipelines and think they're done. In the same way that many organizations who think that they have accomplished DevOps have done so by giving someone a title of DevOps and making sure that they have access to AWS. That's not really all there is to it. As we've seen from the previous discussion of the 3 ways and all of the philosophies that are required to really achieve a DevOps culture, there's more to it than just slapping a title on someone. So the same principle holds for DevSecOps. All of the principles of DevOps apply within a DevSecOps organization. So merely shifting left is not enough. Now, when we look at a software factory in the DevSecOps concepts, what we see is that there are a series of stages of tests that are added to the CI/CD pipelines at the various testing stages, at the various logical gates. You have these same tests in a DevOps pipeline, such as unit tests, system integration, and acceptance testing. However, when you begin your security shift left motion, you add security tests with various software packages and capabilities, both technology and procedural, to these logical gates before your software workloads are allowed to promote through to the next stage. The problem is that when an organization takes this approach and all they have done is added vulnerability scanning, etc., into their tests, that's not enough. It doesn't take into account the feedback loop mechanisms that we learned about before in the DevOps philosophies. It doesn't take into account the continuous monitoring that's taking place in the operations phase. So shortly, we'll talk about one of the principles of DevSecOps. And the operations component of DevSecOps, according to the Department of Defense model, is that the operations requires all of the logging and all of the security knowledge gained from these early stages in the software factory to also feed the findings into your security information and event management systems, your SOAR platforms, all of the other systems that are used to handle your operational security. That way, all of the teams have visibility into the activities and into the security problems that are developing within the organization. So let's talk about why this isn't enough. One of the fundamental problems in the DevSecOps world is that the 3 teams that comprise DevSecOps, the developers, the security teams, and the operations teams, they're all incentivized differently. Developers are incentivized to get code to market fast because they have marketing teams and sales teams and product roadmaps that are requiring that those feature sets get to market to be able to take advantage of the business logic and the value that they're able to bring. The operations teams are incentivized to make sure that those workloads stay up, stay stable, and stay highly performant, where the security teams are incentivized to make sure that they're reducing risk. And unfortunately, this frequently slows development. So as a result, when the security team identifies problems in many cases, a siloed organization where each of those three teams are running separately, the security team will identify these problems and put in policies that prevent the workload from being able to make it to production. And as a result, that means that the features and capabilities for business that are required in order to get that code to market are hindered. So security becomes the team of no, and this becomes a contentious relationship rather than a supportive one. So the idea behind shift left is to move all of this discovery of the security problems earlier, where yes, it's less expensive and more efficient to solve these problems. But the problem is that once the vulnerabilities are identified, let's say you identify them in these various testing stages, which we'll get to in a minute, the problem is that the security teams are required to help the developers understand the context of why the security challenge is a blocker. If the developers knew up front that these security challenges would prevent promotion, they would have taken care of the problem in the first place, right? Developers want to put out perfect code. They're not trying to put out code that's vulnerable, but they can only know what they know. So the security teams have knowledge of security, and the developers have knowledge of how to develop the business relationships and the business relationships within the software in order to achieve the objective. But those two teams need to come together more appropriately. So shift left helps, but the security teams are already stretched too thin. Remember, we talked about the 1,200 to 1 ratio of developers to AppSec security teams. It's not a tenable scenario. There's just too much work for the AppSec teams to do. So we'll talk about some of the solutions to that here momentarily. But as you can see, at each one of the logic gates, you have security testing in a DevSecOps software factory. This is good. It's just that it's not enough. So as a result of these problems and the disconnect between the teams, you end up with technical debt, i.e. vulnerabilities that need to be remediated, security team burnout, high turnover, siloed teams, we've talked about that, and as I mentioned, it leaves out the entire operational feedback loop. So when we look at a solution to this, the idea of shift left being inadequate, we end up with the concept of shift everywhere. Now, this is something that was making its way around the marketing hype in the security world for a while. But really what it is, it's about including security at each step in the entire DevSecOps lifecycle. And this is what this entire course really boils down to, is this concept here. As you can see, this is security that's been added. You have security right here in the middle as the glue that holds everything together. But what you add is security capability at every single one of the stages in the two development and operations cycles that we talked about before, all the way around. I believe there are 15 different stages. Now, what this does is it gives you a comprehensive security view of your code throughout its entire lifecycle, from planning all the way through operations, monitoring, and feedback. By integrating security earlier and earlier in the stages, going beyond purely shift left, but all the way into the planning stage, you're able to make sure that you are solving these problems as early as possible, all the way through testing. And then as you monitor the workload, you're able to feed that back. Security analysis ultimately feeds back into your planning stage again. We'll talk about all this in just a moment. But as I mentioned earlier, the DoD model states that the operations part of DevSecOps means every stage should be integrating into an organization's SIM and SOAR capabilities. So what this does is it empowers the feedback mechanism and data mining for analysis later. So as you can see on the slide here, as we move through the 10 different stages of DevOps, plan, develop, build, test, release, deliver, deploy, operate, monitor, and feedback, we have security stages that exist as well. In the planning phase, you have threat modeling. Threat modeling is when you take experts in security and in the workload you're trying to develop, maybe the architects or the lead developers, and they basically sit around a table and they discuss what are the problems that could arise with the architecture that's being considered for this particular workload. If you're hosting a website, could a man in the middle intercept that traffic and tamper with it? The solution to that is using HTTPS. That's a fairly simple solution. You make sure that's included in your design plans before you've written a single bit of code. Next up is secure coding. This is the concept of making sure that you have approved libraries and that you have security tooling built into your IDE for the developers to leverage, and that you have policies in place and standards for the developers to be able to use as they're doing their work. Next up, security as code. This is the notion of the IDEs having security capabilities built in so that as the developers are working, they're receiving updates to their code within the tool set itself. Next up is SAST, or Static Application Security Testing. SAST is a method for scanning code that's been written in order to identify security vulnerabilities that exist within the code before it's been run, before it's been deployed. That's why it occurs at the build stage. Next up is DAST, or Dynamic Application Security Testing. DAST requires an environment for it to run in. So typically this takes place at the testing stage in a staging or test environment so that you have as close to a production-like workload running as possible so that the DAST tools can evaluate what happens under certain circumstances. This is fuzzing and things like that allow for code to be tested while it's running so you can observe the behavior of the code. It's not just theoretical as SAST, it's what's really happening. That's DAST. Next up in the testing phase is penetration testing. Typically this is manual, but you have lots of automation tools and scripts that are available for your penetration testers to be able to leverage. Once you've processed all of those different security tests, maybe a set of code is rejected and gets sent back to the developers to rework it. And you'll go through those stages over and over again, just like you did on the regular DevOps cycle. However, if you have a set of code that's ready to be released, it'll be kicked out, and you have the concept of digital signatures that get added. So as your release package candidate is created, you'll have hash algorithms and whatnot that are added to the code in order to prepare it for delivery so that when it's received by an end user for deployment, they are able to validate that the code was not tampered with and that it has remained the same from the time that it left the compiler and the other packaging tools all the way to the end user where they're going to consume that code. So that's digital signatures. Next up, secure transfer. In this case, the end user needs a way to be able to receive the code securely. Think Windows Update, for example, or the App Store or Google Play. Those are secure transfer mechanisms that ensure that the software that you're consuming from the repository that it lives in, Windows Update, Google Play, etc., that by the time it gets to you, it is untampered as well. So there's a whole security mechanism that goes along with making sure that supply chain from the consumption source to the end user is unhindered and untampered. Next up, deployment. When the software is deployed into an environment, whether it's on an end user's laptop or whether it's into a cloud environment, you have the notion of security configuration. So there's configuration files that need to go along with your code in order to make sure that it's deployed appropriately with the right security controls in place, whether that is an encryption suite that's required in order to allow a load balancer to handle encryption for a workload that's running in the cloud, or whether it's a firewall policy that needs to be added to a laptop. That security configuration comes along and is not part of the code, but it's required for the code to operate properly. Next up, security scanning. For a cloud workload or for a laptop, it might be vulnerability scanning in the cloud, or it might be endpoint management solution that's going to look at the software packages that are running on a device in order to identify, are there deprecated software packages that need to be updated? Are there security flaws? Think of your CrowdStrikes and your endpoint protection software or your vulnerability management software that does this for larger systems. When you get to the operations phase, a lot of what needs to happen is security patching. Backups is part of this as well, but this is what is required in order for a workload to be able to operate successfully and securely while maintaining the CIA triad that's required for all security workloads. CIA triad, if you're not familiar, is confidentiality, integrity, and availability. Those are the three tenets of cybersecurity. Confidentiality means making sure that the data is available to only the people that are supposed to have it, keep secret. Integrity is making sure that the software and the data is not manipulated inappropriately, that it remains the way that it's supposed to be. That's the purpose of the digital signatures before. And availability, which is the primary role that operations teams are trying to achieve, is making sure that data is available to the people that need it at the time that they need it. So that's making sure your workload stays running. So that's the CIA triad. And security patching is part of the operations phase in order to make sure that occurs. Next up, security auditing, everyone's favorite subject. That's an important phase to make sure that all the things that you said you were going to do to keep your workload secure is actually happening. Next up in the monitoring phase, we have security monitoring. You're monitoring not only for performance and uptime, but also for bad guys doing bad things at a particular time. We talked about runtime protection before in the API portion of the introduction. That occurs here as well, security monitoring. So your SIM and SOAR tools are there to monitor what's happening in the logs and to provide the SOC team, your security operations center, with the information they need to be able to make informed decisions about how to triage and respond to threats. Last but not least, security analysis. Security analysis is the process of going through everything that we've learned through the entire life cycle thus far, especially here on the operations side, and making sure that it's available and used to feed back in that feedback loop mechanism that we've talked about into the planning stage. So your next development cycle can take advantage of the learnings that has occurred in the operations side. Okay, as promised, we're now going to reveal the location, the top secret location of the Department of Defense DevSecOps Strategy Guide. It's not really top secret. I just happened to find it, and I believe it is a really good resource to guide your DevSecOps activities. It's a framework of sorts to establish a measurement by which you can guide your activities. So it's available here. The DoD Cyber Exchange is a public resource that's available. There's the specific document that I've used to generate a lot of the materials for this course, as well as the broader library of content. Both of these links are here on screen now. Now, what we're going to talk about next are some of the guiding principles behind DevSecOps. Now, the DoD framework uses a couple of confusing terms. They say both guiding principles and key principles. So you'll see both of those over the next few minutes. The number one, in my opinion, is psychological safety. All too often, we hear about security breaches that occur, and as a result of that, heads roll. People end up getting fired. The CISO's out, the AppSec team leaders out, etc. This sort of mentality ends up breeding a culture of fear, which results in lack of transparency. People are afraid for their jobs. The stress level's too high. They're not able to deal with it. And so you end up with the opposite outcome of what you're looking for from your security team, which is concealment of the security challenges that really need to be solved. When you have a culture of psychological safety, in other words, transparency is supported and ideas are encouraged and feedback is encouraged and true learning is encouraged, rather than blaming or finding out who's responsible for a certain problem, you're able to have a culture that enables security to truly improve and for people to have an environment that's safe and healthy to work in. And don't we all want that? So psychological safety is one of the key guiding principles for the DevSecOps framework according to the DoD, which is a very encouraging part of this. Next up is Agile, the relentless pursuit of Agile principles and culture within a software factory construct. Now, we've talked about Agile before when we were looking at Waterfall versus Agile methodologies for project management, but that applies even within DevSecOps, which is why I brought it up before, and it's reinforced here. The Agile Manifesto is 4 key phrases that are used in order to guide how Agile gets done. Now, I don't presume to be an Agile expert, but these principles are what really drive Agile. And so here we go. Agile Manifesto. Number 1, individuals and interactions over processes and tools. I'm going to go through each of the 4, and then we'll go back and we'll drill in a little bit more deeply. Working software over comprehensive documentation. Customer collaboration over contract negotiations, and responding to change over following a plan. So notice that the word over is used in each of the 4 manifesto ideals. What that means is not that processes and tools are not necessary. What it's saying is that individuals and interactions take precedence over processes and tools. You must have processes, you must have tools, but you can't blindly follow them. You can have important business decisions that need to be made in order to achieve an objective for an organization. And if your processes and tools don't allow for that, then the individuals and the interactions that they are attempting to conduct need to take priority over the process and tool itself. Same is true for working software over comprehensive documentation. Of course, you must have documentation, but when you're given trade-off that needs to happen, the important thing is to have working software, not the documentation. So when there's a trade-off, That's what you're looking to achieve, is that balance. But the working software is more important than the comprehensive documentation in an agile methodology. Customer collaboration over contract negotiations. You may have a contractual problem where something has gone a little sideways. It's much more important in the agile world to work with your customer and to make sure that you achieve that objective than to, again, blindly adhere to the contract or to negotiate it out and slow things down. Last but not least, responding to change over following a plan. You must have a plan. However, the plan never a plan never survives first contact with the enemy, right? That's an old saying that we use. Following the plan is important, but when things change, when the reality of the situation on the ground is different than what you expected, you got to respond. Otherwise, your plan is going to fail no matter what. The next set of principles is software supply chain. Now, I added in some more of these rather disturbing AI images. I apologize in advance, but it was that or looking at a black screen with a bunch of text. So here we go. Software supply chain. See what I did there with this particular AI image? Software factories mandate baked-in security via integral and comprehensive security practice across the entirety of the software supply chain, leveraging zero trust and behavior detection principles. So zero trust is the concept that just because you're inside of a perimeter doesn't mean you're a trusted entity. That's the whole concept behind land and pivot. Some of the items that I discussed earlier around ransomware landing and being able to move laterally in an environment. Zero trust is part of what prevents that. And so zero trust means every single API call is authenticated. Behavior detection principles goes along with the zero trust concept in that if you have an authenticated call that was being made in California, and then just a few minutes later, it's being made from the Philippines or North Korea, something ain't right. So you need to evaluate the legitimacy of that particular activity. Next up, integrated, automated, and continuous end-to-end testing and monitoring from ideation through production with clearly defined control gates for release candidate promotion. That's what we saw in the slide before with the DoD model and its set of infinite loops. That continuous end-to-end testing and monitoring is right there in the diagram, and it's held up here in the guiding principles as well. Next up, immutability of infrastructure achieved via X as code design patterns. So we have infrastructure as code, security as code, configuration as code. When these things are written and enforced by software, you're able to have very consistent results. And if something goes sideways, you just redeploy. And so that immutability of the infrastructure, because it's codified in a CloudFormation template or Terraform or whatever your deployment methodology is, you're able to achieve a much stronger security status because hands on keyboard are prone to mistake. Humans are the ones who tend to make mistakes. Whereas your software being deployed as code, it's much more likely to be accurate each time it runs. Last but not least, adoption of cloud smart and data smart architectural motifs throughout. This is a concept that I struggled with a little bit getting ready for this course. Having spent some time at AWS, I'm aware of many cloud capabilities that organizations need to consider when they are deploying software. But the idea of cloud smart threw me for a bit of a loop. What they're referring to here is the notion that if you take a workload that runs on premises and just throw it in the cloud, thinking everything's going to be better because it's in the cloud, that's not really understanding the point of the cloud. It's not taking advantage of its real strengths. The strength of the cloud is in its scalability, software constructs themselves that enable you to deploy anything as code, infrastructure as code, functions, etc., that can all be deployed via software constructs. As a result, the methodologies that you use to build architectures are different than what you're required to use for an on-prem environment because it's all software composable. So using cloud smart capabilities, i.e. architectural design patterns that are cloud aware and cloud native design will allow you to take advantage of the high availability and resiliency and scalability of the cloud that gives you a more resilient and performant architecture. Data smart is the same thing. The data that's generated within the software factory itself is important, not just the code that's being generated, but your logs, the way that you deliver that data, the way you deliver the packages. All of that is relevant to the workload itself, and you need to treat all of it with security and intention in mind as you deal with it. So being aware of the cost of data, the speed of data, how long it takes for data to be delivered. Just being aware of the code is not enough. The data itself is part of the consideration. All right, and here we are at the DevSecOps key principles. As I mentioned, there's some confusing terminology between guiding principles and key principles, but now we've arrived at the key principles. Couldn't tell you what the difference is, but this is how the DoD frames their two sets of principles, and there's quite a bit of overlap. The first of the key principles is continuous delivery of small incremental changes. Now, we've talked about that already with the first way, I believe it was, in the DevOps universe, as it were. And the idea here is to make sure that as you're making security changes, continue to keep those small and consumable. Don't try and boil the ocean. Make your changes one small piece at a time. This also applies to business functionality, etc. as well. So the same principles apply in DevSecOps as apply in straightforward DevOps. Next up, bolt-on security is weaker than security baked into the fabric of the software artifact. So we talked about this a little bit on the guiding principles, but here we have a lovely, slightly disturbing AI-generated image. See what I did there? Security baked into the bread. Haha. What we're getting at here is that you can have security controls, such as a web application firewall, that are bolt-on is how they're describing it here, but it's really a compensating control that goes around the application. You may have a vulnerability in your web app that allows for SQL injection. So the solution is just throw a WAF in front of it and you're going to be fine. The problem is that doesn't address the underlying actual vulnerability. This is it's like putting a lock on a door. Yes, the lock is there on the door, but if you still have all of your jewels sitting out in the front window so everyone can see them, all someone has to do is break the window and come through and get all the jewels. So in this case, what we're talking about is the fact that you should be solving problems in the best way rather than in the easiest way. Now, you may need to do temporarily. Throwing a WAF in front of the vulnerable SQL injection site is absolutely something you should do, but you shouldn't rely on that as your long-term protection strategy. So another example of this is the difference between imperative security and declarative security. I've just talked about the security tooling add-ons. So that's like a WAF or other security tooling you may add into your environment. Let's talk about the difference between imperative security and declarative security. Imperative is when the code itself has all of the security controls built in. Think of encryption suites. In many cases, due to US import-export laws, you cannot use the same encryption protocols and cipher suites for your US-based data resource as you can for the outside of the US resource, especially for certain countries. So you need to employ what's referred to as cryptographic agility. And when you do that, it's very hard to swap out your encryption protocols if you've baked it into the code. If you, on the other hand, and that's imperative security. So if your code says accept a call, here's your encryption protocol, return the call, the response, etc., that's imperative. Declarative security takes that encryption suite, removes it from the code of the business logic of your code, and puts it outside of your actual application where it can be referenced. You may still deploy it as code. For example, if you have a load balancer that can handle your encryption termination, then your encryption protocol and the rules and configurations that go along with that can be assigned with your infrastructure as code deployment. That's part of the overall software package, but it's much easier to swap out that encryption protocol rule set from the load balancer than it is to rewrite your application for every country that requires access to that application. So that's an example of declarative security, which is superior to imperative security under most circumstances. Now, there may be expert developers who would disagree with that. I'm not trying to debate the philosophical differences, more to explain the general approach that we should be taking in our security practice. And the third item here is security tooling add-ons. I've talked about that already. Next up, value open source software. This is generally a good idea, and the fact that it's embraced by the DoD DevSecOps model is fantastic. I don't think there's anything more to talk about here aside from just to be aware that Just because something is closed source doesn't make it more secure. Generally speaking, open source is preferred because you have an entire community that is looking for vulnerabilities and addressing them and remediating them. And it's a bit more transparent. Next up, number 4, engage users early and often. This is adhering very much to the Agile approach that we talked about earlier. When your end users or your customer is involved in the process, they have a say in how the application is developed and how its outcome proceeds. You have the same principle applying here in DevSecOps. Next up, some more key principles. There are a total of 11. Prefer user-centered and warfighter focus and design. So warfighter, again, this is the DoD framework. So warfighter in our context for the private sector typically means more along the lines of end users or the people who are going to use your workload most critically. You want to make sure that you're designing applications based on the usability for the end user, not on ease of development for the developers that are putting it together. So keep that in mind as you're working on your project. Number 6, value automating repeated manual processes to the maximum extent possible. Now, this is something that I alluded to earlier when we were discussing the problem that we run into because of the disparity between the number of developers that are in the world versus the number of AppSec engineers. The AppSec engineers can't keep up. One of the solutions is automation, and that is right here in one of the key principles. This is what they're referring to. Automate everything that you can. Infrastructure is code. Configuration is code. Security is code. All of these capabilities are highly automatable, therefore can save your teams lots of time, and it makes them more reproducible. You don't have a bunch of GUI interface interaction in the AWS console, for example, when you're deploying via CloudFormation. So that automation is key. Next up, fail fast, learn fast, but don't fail twice for the same reason. I mentioned this earlier when we were talking about experimentation. Yes, take the big swings, make the big bet. When it doesn't work out, or if it doesn't work out, learn quickly, learn from those mistakes. Make sure you document them and move them forward. That's part of the feedback loop mechanism as well. Something doesn't work, feed it back into the design process so that you're learning from that mistake. Next up, fail responsibly and fail forward. Now, this is an interesting concept. Anytime there's a deployment, we always talk about, what's your fallback plan? What's your failure plan? How are you going to roll back to the previous version? For an immediate deployment, that can make a lot of sense. But if you deploy and you discover an unexpected problem, then it can make sense if your triage of the scenario suggests that it's possible to fail forward. In other words, revise rather than fall back. Revise the code, correct the problem, redeploy with the new version. It can be better to fail forward when you can, because it can take just as much time to fix the problem in the previous version as it does to fix it in the next version. Therefore, if possible, fail forward. So that's what they're referring to there, is make sure that you start to look at that when your organization is ready for it to be able to fail forward. And that can save you time and it's more efficient. Number 5, this is particularly relevant to this course. Treat every API as a first-class citizen. One of the problems that we have in API landscape overall, as I've talked about, is that organizations don't even know what APIs they have. The documentation lags far behind other pieces of software. So treat your APIs as a first-class citizen means give them the respect they deserve. They're gaining access to your data. They're providing mission-critical capabilities to your business partners and to your customers. Take advantage of that respectfully and give those APIs the recognition they deserve. Next up, number 10, good code always has documentation as close to the code as possible. In the API world, this is particularly true. We talked about in Agile, functional software over documentation. The API documentation is referring primarily to OpenAPI spec files or Postman collections, preferably the spec files because that's an open standard. However, one of the fundamental problems is that organizations don't have good documentation, and they certainly don't have it anywhere that's useful. The best organization I ever saw when I was working at No Name was a company that had, at the very least, they had a GitHub repo for all of their OAS spec files. And that was it. Even though that one tiny action is as small as it is, it still put them leagues above everybody else that didn't have that. So what would be even better is if that GitHub repo was the same repo or a neighboring repo or a sub repo of the actual developer source for the workload in question. What this security team was doing was saying, hey, we need a GitHub repo where all of the OAS files reside so that they have visibility into them and control. And then what they can do is they can revise them. We'll get into more of that when we get to the kind of the active testing side of the world and talking about OAS file hygiene when we get to the third portion of this course. But that notion of having your documentation close to the code is really good, especially for the API world. Number 11, recognize the strategic value of data. Ensure its potential is not unintentionally compromised. This is really just making sure that you dot your I's and cross your T's. We talked earlier about that most of the security failures that occur are eat your vegetables types of problems. This is an example of that. The data itself is the new perimeter, so let's make sure that we're protecting that data and leveraging best practices so that unintentional mistakes don't occur. Next up, governance. Now here's another nightmare scenario of an AI-generated image, but I decided to keep it anyway. I think that guy's legs are on backwards, that's hanging upside down. The idea of governance around your security program is very important. And in the API world, it's just as important. So governance top down and bottom up. So here we have two generals governing from the top and one lunatic general governing from the bottom or hanging on for dear life. The idea is to make sure that you have buy-in from the very top, that your policies are aligned with mission objectives, with governance, with the overall organization's objectives, and that your boots on the ground people are also marching essentially to the beat of the same drum, that they are approaching their day-to-day work and on the tactical level from the same objective set as the top level. So run IT with mission discipline. What they're referring to here is, this is again from the Department of Defense. So their primary objective is go win battles, achieve large-scale military objectives, and make sure your people come home alive. That's mission discipline because lives are at stake. So everything is very important. Maybe in some parts of the military culture, IT is seen as less important perhaps. And so as a result maybe it's a little sloppy. What they're referring to is make sure that doesn't happen. Make sure that you run your IT organization with the same degree of clarity of purpose that you have when you're out engaged in a hostile military activity. I'm not a military guy. I'm interpreting this myself, but that's the way I understand this. Number 2, invest in automation. So this is governance. This is how do you get the thing done at the larger scale and enforce it. So automation, as we talked about just on the last slide, allows that to all happen, infrastructure as code, et cetera. So you make that investment, you make sure that you are working within the workload as you develop, as well as work on what surrounds the workload in order to make sure that it functions the way that you intend. That's the investment. And we're going to talk about that more when we get to resourcing shortly. Next up, embrace adaptability. This is the Agile idea where no plan survives first contact with the enemy, I think I mentioned. So the plan is important, but being able to be nimble and respond to changes on the battlefield is equally important. So embrace adaptability. Don't be rigid in thought or execution. Next up, promote transparency. We've talked about this as well. Transparency makes sure that everyone's on the same team. Secrets don't help anybody really. This is about making sure that your team is working together. Next up, inherent accountability. This is one of the 3 tenets that follow on from CIA. We talked about the CIA triad: confidentiality, integrity, and availability. The other 3 components of that are AAA, which is authentication, authorization, and auditability or accountability. That's one of the core tenets that make sure that you're able to execute on CIA is the AAA component. You are who you say you are, you have access to the right thing, and you can prove it. So that's auditability. Inherent accountability means making sure that activities are logged, that there is the ability to not claim that you didn't do something when you did. That's the idea of non-repudiation. That's part of a hanger-on to the AAA concept as well. And last but not least is metrics. We're going to have a whole section on metrics, but being able to measure your workloads and what's happening is important. You can't manage something if you can't measure it. You can't improve it if you don't have something to measure against which you're getting that line to move up and to the right. So metrics are also an important part of your governance strategy. Now, coming back to the same image that we had before, just to bring it all home, We have 15 different areas of security concern that surround the 10 different objectives behind, or the 10 different phases behind the dev and ops cycle. This is really just to remind you that it's a continual cycle. It's not a one and done type thing. You're constantly going to be going through these activities. Security is a journey, not an objective. And this is to remind you of that. Now, what we're going to do is we're going to talk a little bit about API security more specifically. Again, this is just going to be an overview. When we look at these 15 areas and we think about them in the context of APIs, in my view, there are a few that are more important than the others. And those are threat modeling, DAST, the dynamic application security testing, pen testing, security config, security scan, security patching, audit, monitoring, and analysis. So most of the operations side. On the development side, when we get to the API security deep dive in section 3 of the course, we will talk about each one of these. But from an overview perspective, the important things to think about are as follows. Threat modeling has more to do with how you're planning out your workload. And the work that you do before any code is written is important because it improves the efficiency of the rest of your activities through the coding phase. Because if you catch a problem here, you're catching it before it becomes a problem later on. So threat modeling and making sure you understand the threats to your APIs potentially prior to actually writing the code can make a big difference. Next up, dynamic application security testing. APIs are about code consumption, not about code as it sits. Your OAS spec files, technically, yes, those can be scanned on your SaaS side of the world, but that's not the primary thrust. APIs are about how does your code get consumed, so it's much better to be testing it in a DAST concept. And most of the API security tools out there do treat API testing as more of a DAST-like activity. Penetration testing, also very API security relevant. Be aware that there are different, let's say, flavors of API penetration testers out there. Some of them do an amazing job, some of them not so much. So buyer beware and make sure you're getting an example report from multiple vendors before you choose an API security penetration tester. If you need any recommendations, by all means, please reach out. We're happy to point you in the right direction and help. Next up, security configuration. This really has to do with vulnerability management, making sure that your infrastructure is handling your APIs the right way. There are governance capabilities that can be added at the load balancer, at the API manager level, at the API gateway level. So that's around security configuration. Security scanning. This is, again, vulnerability management, looking at how your APIs behave and providing insight into the vulnerabilities that may exist in how the API performs and behaves before it's taken advantage of on your kind of shift right on the security monitoring side. So we'll get to that in just a moment. Next up, security patching. Remember, as you update your APIs, you may rev them from version 1 to version 2. If you've got a breaking change to make a security change or a functionality change for version 1, you may need to rev that to version 2. Remember, inventory management is critical for APIs because if you have a security problem in version 1 of an API, you rev it to version 2, and as a result, you no longer have that security problem. That's fantastic. But what if you leave version 1 active? You're not pointing anything at it anymore, but if someone can just go into the URL and change that to V1 and still take advantage of the security problem that exists, you haven't really solved your problem. You've just hidden it. So security patching is very important in that you're getting to that version 2 level, but also that you manage the inventory and deprecate the old one and make sure that it is actually gone. That's one of the primary security risks. Next up, security auditing. Your APIs need to be audited just like anything else. Security monitoring. This is the shift right concept that we talked about for runtime protection of the 4 API security principles. The security monitoring is going to give you visibility into things that are happening at a particular time. These aren't hypothetical security vulnerabilities. These are real world things that have happened, whether it's anomalous behavior or whether it's actual breaches or exfiltration of data. Security monitoring is where you're going to see that happen. And last but not least, security analysis. Again, all the lessons that you've learned from the operations phase can feed right back into your planning stage for the next go round. Now, this is another view of that same thing that's broken out a little bit differently. This is, again, from the DoD model framework documentation set. What this does is it takes that same infinite loop graphic that I like quite a lot, and it unpacks it and turns it into a timeline. And it shows you where your different capabilities exist across both the CI/CD universe and your DevOps model, as well as where each one of those logical gates, the different control gates that are in red and black, shows you where each one of those take place in a timeline. So if this works a little bit better for how your head works, then by all means leverage this. Continuous build, again, is development through the build phase. Continuous integration extends over into the testing phase. Continuous delivery is the entire process from planning through release. So it's the entire dev cycle on the left of this graphic down here. Next up is continuous deployment. That goes all the way through deployment. There are organizations that are ready to deploy software into production. Not every organization is ready to do that. Most of the time, the concept behind CI/CD continuous delivery means you have a manual gate to approve release of software into production for the deployment. Delivery is not the same as deployment. So if you have made the evolution to continuous deployment for some or all of your workloads, that means that when all of your tests are passed, code is passed directly onto deployment. That's the holy grail of DevOps to be able to get to that point. It's highly efficient, but you have to have made a significant investment in all of your automation steps that lead up to that. Last but not least, continuous operations. What this is doing is looking at the risk of your entire life cycle across the cycle from planning all the way through operations and monitoring, et cetera. Your entire process is continuous operations. That's part of the objective behind DevSecOps, is to make sure that you have security integrated at every step, as we talked about before. Now, what I've done here is I've added the arrows from my previous example of where there are API relevant pieces, and I've highlighted them here as well. I've called them out and labeled them for DAST on the testing side. This is when we're looking at kind of technology-centric tools, hence the name of the slide. There's always technology, people, and process. Sometimes when I give this talk, I break it down into technology specifically, and we look at the tool sets. We're going to be doing a much, much deeper dive into all of the technology pieces behind each stage of the DevSecOps lifecycle and every activity that takes place within each stage. So this is going to be a very comprehensive view, and we'll look at all of the technology involved. But from an API security overview, the technology-heavy components are DAST, which is where you have the security testing tools that are running against a security test or stage environment. And then you have security scanning. This is vulnerability management. Many of the tools that are posture management tools in API security will be looking at running workloads in production, evaluating how does your API behave, what sorts of data does it have access to and return, and how does it perform. And then that is where it highlights vulnerabilities for you in the way that your API security may have areas of improvement. So the security scanning side of things takes place there as you are deploying and operating your workload. Last but not least, security monitoring. This is really the runtime protection side of things that takes place on running workloads that are being monitored at all times. If we hop over to now a quick view of the processes side of the world, those same API relevant arrows are in this diagram, but what I've done is I've highlighted them and labeled them from a process perspective. So the parts of API security that are more heavily reliant on process than they are on technological tools are, starting with the planning phase, and we'll work our way around, threat modeling. Yes, there are tools you use for threat modeling, but primarily it's people sitting around talking about a workload before any code has been written. Therefore, it's more of a process stage in advance of code being developed. So this is process heavy, even though you may enter all of your results or use a tool that helps you identify a remediation strategy for a particular vulnerability that you have identified. It's mainly process driven. Next up, penetration testing. Yes, obviously penetration testing is a heavily technology dependent capability, but from a consumption standpoint, as the consumer of a penetration test, it's really process. You're going to engage with that penetration tester. You're going to have a scope of work. You're going to have rules of engagement, what's inbounds and out of bounds, how are you going to approach that? And then the penetration testers as a third party are going to go do that activity and come back to you with the results. You don't want to be penetration testing your own workload because you know it too well. You need someone else to do that. So that's primarily a process-driven activity. Next up, security configuration on deployment. This is where you interact and engage with your governance group. I consider that more of a process consideration than heavily technology dependent because you need to determine what are your policies, and those policies need to be written up. When they're enforced, when they're automated, that becomes a technology decision or a technology capability. But the decisions and the activities that lead up to that, primarily process driven. Security patching, think Patch Tuesdays from Microsoft, that is very much a process. Obviously, there's technology involved, but from a consumption standpoint, mainly process-driven. Security auditing, definitely process. And last but not least, security analysis, also very process-driven. So those are the kind of the process-centric viewpoints of the different API security capabilities. And last but not least, we get to the people side of the equation. The people are the ones who are doing all of the work. Automation's great. AI, generative AI, agentic AI, all of the latest buzzwords are all fine and dandy, but there's still people responsible for getting it all done. Now, we've talked about the difference in incentives that are from the three perspectives of developers, security teams, and operations. And that incentivization really becomes the fundamental problem behind how we ended up in this situation in the first place, aside from the workload discrepancy between developers and the number of people there are that are doing the work versus the security teams. But when you have a gap or a conflict inherent in the way that these teams are incentivized, you're exacerbating the problem. So the hypothesis here is dev teams are paid and bonused on getting features to market fast. Your ops teams are incentivized to make sure that your running workloads are stable and performant and recoverable in the event of failure. And last but not least, the security teams are paid to really defend data, defend the organization against vulnerabilities and malicious actors. So what this incentivization disparity results in is silos. Teams work very separately in traditionally organized groups. You have skills gaps. Your dev teams may not be aware of all of the security capabilities that they should have to write into their code. That's how we end up with the vulnerabilities in the first place. If they knew the right thing to do, they would have done it because they want their workload to be perfect. They have great pride in their work, but you can't know what you don't know. On the other hand, the security teams are generally known for not being fantastic developers because they've spent their time learning the security side of the world rather than learning business function and coding. I'm not a developer myself, so that absolutely applies to me. But CISOs that are trying to hire security folks that have coding chops have a lot of trouble finding folks that can do that. So it's a pretty common gap on the security side is that the developer chops are not as solid. And they may not know operations capabilities as well. And on the operations team side, they're lacking both security knowledge in some cases and coding for the business logic. Now, they may be good at scripting and at automating workloads, but that's different than building out business logic, and it's different than having security capabilities baked in. Last but not least, resource allocation. We'll talk about this more in a moment, but the resource allocation problem is inherent, and it's talked about a lot in the Phoenix project. And this is really where I got this idea that you can have a series of changes to the way that you allocate your team's time in order to start to improve upon these problems. We'll talk about that a little bit more now. All right, and when we look at the solution to this problem on the people side of the world, what we want to do is really break down those silos. You've got your dev, sec, and ops teams. We want them to work more closely together. In order to accomplish that, kind of the holy grail is this Amazon two-pizza team concept that I talked about before. When you break down your workloads so that the team that's responsible for it is developing it and supporting it, and they have a security, if not a full-time security person, which is usually not possible, but at least a security person assigned to multiple projects where there's one person on the security team who understands that workload and is involved from the beginning through operations, and they're there, that's really where you end up with an excellent DevSecOps structure. Obviously, that's not possible for every organization, especially if you're very siloed on day one of this journey. So what you may want to do, and we'll talk more about this in just a moment on the next slide, is there's some stepping stones to get there. But if your goal is to get to that two-pizza team structure to where you have ownership over your workloads, that becomes a very agile methodology where you have that ownership concept we talked about before. And that's really where you can achieve a very tightly organized DevSecOps culture. Next up, resourcing. 70-20-10. What do I mean by this? The Phoenix project talks about resource allocation and how, in many cases, people that are doing their quote-unquote day job are spending all of their time on that one activity. Let's say you have a DevOps engineer and their workload in the operations side is primarily around pushing code and working on CloudFormation templates in order to handle infrastructure as code. If they're doing that all day long, if they're doing that one activity all day long, every day, and they're constantly putting out fires, taking care of tickets, providing access, resetting passwords, whatever their responsibilities are within that operational world, then they never have time to work on the activity itself to make the activity more efficient. And they never have time to improve their skills. So what the 70-20-10 concept is talking about, and I actually even prefer a 60-20-20 split. What it's talking about here is 70% of a resource's time. So a person who's working full-time for you, 70% of their time should be spent on the day job. So in this example, the DevOps person is working on the AWS tickets, whatever they've got to be working on, only for 70% of their time. So that's going to be 28 hours a week of a 40-hour week is spent on those normal day-to-day activities. 20% of the time, or 8 hours a day, 8 hours a week, is spent on improving the work that they do, process improvement, not working in the process, not doing these skills activities, not doing the ticket activities, not doing the work within AWS, but working on how do they improve the way that they do that, building efficiencies into the system so that the organization as a whole benefits from the knowledge that they've gained from that 70% of their time. This is a feedback mechanism into their own job, and so they're able to improve that. And then the last 10% of the time is spent on skills development. So 4 hours a week, or 8 hours a week if you go with the 60-20-20 split, is spent on the clock enhancing skill set. Now, large organizations like Google, sometimes they'll open that up and say it's not just skills development, but volunteerism, whatever it is, depending on your organization. But I strongly encourage you to consider having paid training time, paid self-study time, paid experimentation time for folks to be able to improve their skill set, work on something that is passionate for them, that's applicable to the job. I'm not saying go let people practice dog grooming as part of their developer job, but if you're a developer, 10% of your time should be spent learning security chops or operations skills or infrastructure as code, whatever the thing is that's going to make you better at your job and expand that skill set. The organization benefits from that. There's a really famous allegory of a CEO and a CFO talking about training. And the CFO says, but what if we spend this money and train all of our people and they leave? And the CEO says, what if we don't spend this money and don't train them and they stay? Think about that for a minute. What does that imply? Clearly, the risk to the organization is greater from a lack of skills than it is from a benefit of skills. And the other thing is that when you invest in people's skill set and you let them learn and you're supporting that, that builds loyalty, that builds job satisfaction. Sure, some people are going to leave, but a lot more people are probably going to stay. So give that some thought. Resourcing is an important aspect of how do you clear the backlog. There are organizations that are constantly putting out fires, and as a result, they never have time for process improvement. They never have time for skills improvement. And so they can't get to the point where they're ever improving on things. They're only going to get deeper and deeper into the bottomless pit of work. And that's actually one of the stories that's central in the Phoenix Project. So I encourage you to read that. Gamification for KPIs, key performance indicators. One of the things that can really help teams move quickly is to have a game made out of it. Take your objectives, whether you're trying to improve downtime or reduce the number of vulnerabilities that are in your code, make a game out of it. Create a contest, have a little friendly competition between the different teams. Identify a way for folks to have a little fun while they're achieving these objectives. Next up, social events. I know this is not a social event because you're consuming this over the internet, but one of my favorite ways to make sure that we get teams together and solve this silo problem is get people together. If you are part of an in-person organization, that's a little easier. People will frequently have happy hours and whatnot, but make sure you invite folks from the other teams. Have a DevSecOps happy hour where you invite folks from all of the different teams to come socialize, get together. We're all nerds. We're all going to talk about work. The organization is going to benefit from this, but also people are going to have an opportunity to blow off steam. And then the next time they've got to reach out to the security person, it's not, I got to call the security guy, I'm going to be in trouble or whatever. It's going to be, Pete, hey, you remember when we were hanging out the other night and I mentioned that thing? it's a problem. Again, when we talk about this, let's find a better way to solve this problem. Social events are key to improving your culture and to getting your folks to work better together. Last but not least is cross-incentivization. So we talked about the root of this problem is really the incentives mismatch between your DevSec and Ops teams. This is a problem for the C-suite and for senior management to solve, but if you can identify a bonus structure or incentivization plan that allows the dev teams to help the security team, that allows the security teams to help the dev teams to where they're working at common purpose rather than at cross purposes, that can go a long way towards solving the root problem. I personally do not have a fantastic recommendation for this, but it is something for everyone consuming this course to think about, is how might you be able to implement an incentivization plan for your teams that would allow them to work more closely together and share in the benefit of that shared objective. The last part of the people side of things is a process. How do you go about making that change from heavily siloed organization to maybe the two pizza team, if that's where you're trying to go with this? Number one is a DevSecOps center of excellence. Now, what do we mean by this? Typically, it starts as a Wikipedia page, something really simple. Where do you put best practices? Where do you publish your policies and standards so that everyone knows how to get to them? This is a quick and easy way to get something started. You'll need somebody assigned to be able to take ownership of that and the maintenance of it and make sure that it's a real thing instead of something that dies as soon as one person leaves the team. But that center of excellence should be able to stand the test of time and be able to provide value despite whoever is on the team. So when you stand that up, what that does is it gives you some structure for the other events that come along. Now, the next item on the list is a security strike team. As we talked about before, there's a glut of developers to AppSec engineers. I shouldn't say glut. I should say there's a limitation of AppSec engineers compared to developers. So as a result, developers are paid to get features to market. They're not paid to solve security problems. They typically don't want to figure this out and go solve those problems. One approach is a security strike team. This is actually a service that we provide. But the security strike team can come in with a team of developers that are experts in security in order to come in, descend in, and work alongside your developers to take care of those security problems for them. They'll write their code remediation. They'll implement the best practices, and then they're parachuted back out so that the security problem is resolved and the developers are able to stay focused on the other activities. That's one way of accomplishing this. Another approach is security champions. Now, I know some people feel like security champions is a bad word because essentially what it means is you've got people who are just harping about security and not actually doing anything. What I typically mean by security champions is someone who is in your developer community already, someone who already is doing the work within your application in order to achieve the objective for the business, who has an interest in security, who has been learning security and has proven to be able to do a good job with it. They become a security champion and they bring others along with them in order to build out a security champions program. And that program brings other developers who have a shared interest in security who want to get better at it. And they're all working together to improve that skill set and to spread the security knowledge throughout the organization. It's not just talking, it's actually doing as well. So you go from security strike team to the security champions concept. And then really the DevSecOps Center of Excellence is the data clearinghouse for where all that can live, all that shared knowledge. Next up is sharing best practices. This is really the objective behind the security champions component is how do you get these people to share that information? The Center of Excellence is a place for it to live, but the activity of sharing the best practices, maybe you've got a lunch and learn once in a while, etc. But make sure that those best practices are being socialized across the organization. Next on the list here is technical trainings. I've seen panels of CISOs get together and talk about how do we solve the skills gap problem, and technical training is about as far as they get. They don't think about some of the other options that I put forward here, but that's because they're focused on solving security problems, not necessarily on solving people problems. So I don't fault them for that. But when you're thinking about how do you solve this from a personnel perspective, from a culture perspective, it has to go beyond purely technical trainings, but that is also part of the solution. So make sure you offer those trainings. And they should be paid, as we talked about with the resourcing time, the 70-20-10 split. If you're offering technical trainings that's required, probably shouldn't have that be part of that 10%. The 10% should be to fuel the passion that the individual has for a particular area where they can improve their skills. And last but not least, carrot versus the stick. You're going to get more mileage out of your team if you incentivize them, if you offer rewards, bonuses, prizes, whatever it is, which is the carrot model rather than the stick model. This goes back to dangling a carrot in front of a horse so the horse will go after the carrot versus using a stick to whack the horse to make him go. All too often, there's a punitive approach toward security remediation or toward getting people motivated to do something. Sure, it works, but wouldn't you rather be working toward a positive reinforcement rather than avoiding a negative reinforcement? So think about that as you're developing your incentive program, contests, prizes. How do you get your people to just have a little fun with this instead of it being a slog? I know what we're trying to do is avoid really bad things. That's the purpose of security. There are bad people out there trying to take advantage of us, but at least our day jobs, we can be having a bit more fun. So think about the carrot versus the stick as you're finding solutions to these problems. We're nearing the end. Quick reminder, what are the stakes? I just mentioned we're trying to avoid really bad problems. These are nation-state advanced persistent threats. These are organizations from the government that have made horrible mistakes and released incredibly dangerous tools into the wild that probably should never have existed in the first place, but they did. Enormous costs, business impact, and don't forget, cyber combat now precedes physical combat. So these are literal war activities. That's what we're trying to protect against. So just keep that in mind as we're trying to solve these problems. Up next in this course, we talked about part 1 now. We're complete with part 1. Congratulations, you've made it. Up next is going to be part 2. That's going to be a DevSecOps deep dive. All of the 15 steps around that 10-stage DevOps lifecycle, all of the 15 components of security and a few extras we're going to talk about at great length, including the technologies and the processes involved around the entire lifecycle. It's going to be a very deep dive. That'll be the next course that we publish. And then part 3 will be an API security deep dive. So we're going to take all of these pieces, put them all together, and how does API security live in this world of DevSecOps? Once you're armed with all of the knowledge, this has been the overview. Next up is the deep dive into DevSecOps specifics. And last but not least, the API security deep dive. That's, of course, very relevant for AppySec University. Thank you so much for your time in completing this course. I hope you've enjoyed it. I've enjoyed putting this together. You can contact me on my email and LinkedIn here. Really happy to hear from each and every one of you with any questions you have. If you need help with any of the DevSecOps or API security capabilities that we've talked about, that's what we do at SIS, and happy to hear from you. Good luck with your DevSecOps transformation. Take care.
And that's a wrap on DevSecOps Part 1. Thanks for joining us on this journey into secure software development. If you'd like to test your knowledge and get certified, just head on over to appysecuniversity.com. You'll find a quick quiz that takes only a few minutes, and once you pass, you'll earn your free certificate. It's a great way to validate your skills, share them with your team, employer, and on LinkedIn. Thanks again for learning with us. And if you want more practical training, be sure to check out our full course catalog on AppySec University. See you then.